about the sample. We use two few small sample rate to cause some strange phenomena, as you can see. And how about the condensation level? For the condensation, we use two fields condensation level. We will lead to polarization of the Moyer effect in images or condensation noise in sound. Okay, so I will give you some examples about what is talked about. Okay, here you see. Here, this we just show we use the different gray level to show the gray color from the white color to the gray color. For this one, here we use the 2056 level to show the color from the white to black, and in the middle are gray. You know, you have a different level, the gray color. Maybe you can check the smallest one, the bottom one. For this one, we use just two gray levels to show the white and black. So for white, you cannot see because the background is over bright. So you can imagine that there is a white color bar, and this is the black. You just have two levels to describe the gray color. And how about we use the four labels? If you have four labels, here this one is white and this is black, and you have the two more different gray labels to describe the gray color. Okay, if you add more, you can see you will have a more detailed gray label color to describe the gray color. Okay. Okay. So the highest one is used totally 2056 level to describe from the white color to the black color. Okay. So you can see if you use just a few of the condensation level, the change will be the change from white to black is very big, right? The gap is very big. But if you use more gray level, you can see the transition from white to black is very smooth. You can show more different gray color on the screen. I mean, so that you can give a more realistic presentation to the user. Okay, then here this one is we call the Moyer pattern. Moyer pattern is likely. Actually, Moyer pattern is widely discussed in mathematics or in physics or in art. But as you can see, Moyer pattern is actually two different patterns. They are overlapping. For example, this is one pattern. The line arranged like this. And here is another pattern. Like this. So you have two different patterns. They overlap together. So when they overlap, you can see in some place when they have intersection, if your connection level is not sufficient, you will not see very clear about it. About here, just like this figure. So you can see in these figures you have two different patterns. Okay, one is orange, the color is orange, and the other is green. Okay, the code is green. You have the orange color and green color. Okay, and here you can still see them clearly. But when in the center, you cannot, you will see just a map, right? You cannot see them very clearly for each line. Okay, because into here they are getting closer and closer, and the connection level is not enough, so that it cannot represent each line very clearly. Okay, so this is called a module pattern. It's very often to see for any two patterns they overlay together. OK， 好，听得懂吗？好，这种现象叫模类配的。你可以看到它中间的部分是不是其实一团的？你可以看出线条的，你给它 see any line in the middle。那当全部聚在一起，对不对？那你看到好像就一团绿绿的这样。好，那一开始你还看得到每一条线嘛，还看得很清楚。可是越到中间，然后越来越近了，然后你的那个connection level 够的时候，你看起来你这样画之后，看起来像这个样子，一团，这种线，这叫module pattern。So it's what we call a module pattern. It's another example for you can see module pattern. Can you find it? You can see some pattern in this image. For example, here. Do you see? You know, it's the first pattern. Okay? So the first pattern you actually take two or more, maybe more than two patterns overlay. So some patterns are here and some patterns are here. They are of different directions. When they overlap together, so you will see some strange pattern like here. Or for example, this figure here is more unique. I think the direction is more clear. It's unique. But here maybe there are two different patterns overlay together, so you will see a very strange pattern overlay. So it's also called a module pattern. Okay, so if you still feel want to know more about module pattern, you can just type use Google. Okay, you can find some more explanation or videos to explain the module pattern. And there is another case called the posterization. Posterization is original figure. If we use a very few connection level, you will see the colors are very, for this one it's red, but here it becomes red because your connection level is a few. It means you can just use a few of your colors. All the colors you can use is a few. So your representation power, it's limited. All your tools your colors you can use is just a few. So then for this red one, you just use almost a very dark color to present it. Alright, so you can see this figure is not very clear. It's called polarization. So such a phenomenon is very often to see in imaging. Okay, next we talk about the compression. Okay, the multimedia data usually very huge for images or for video. For web data, they are usually very huge. So we also need to do some comparison and so to do some compression and to compress the data volume. Okay, so compression is often applied to media data. It can be lossless or lossy. Lossless means no information will lose in slower compression. So you can recover after you do the compression, then the data, the multimedia data will be smaller, and then you can recover it without any information loss. It's called a lossless. Otherwise, if there will be some information loss between the compression, in the compression process, we will call such a compression the lossy compression. Okay, so for lossless compression, your original data will compress into a small data volume, and you can decompress it into the original data with no information loss. Called lossless. And for the lossy compression, your original data will compress into a compressed data. But in this process, in this step, your information is low. Some information low, so less. And when you decompress it, you will get decompressed data, but this data is not the same as the original data. So we call it lossy compression. Okay, so there are several, a number of different compression algorithms that we use for the various media data types. Okay, so any problems? Okay, next we talk about the representation, the digital representation. Okay, there are several ways to representing the images, videos, animation, sound, and the text in bits. Okay, so media data can be, let's just read this sentence. Media data may be represented as a textual description in a suitable language or as a binary data with a specific structural form. Okay, for image, now we'll give some examples. The first is the images. Images are represented as an array of pixels. Okay, so generating the pixel from the image is called rendering. You just, for example, you show the image into the screen, like this. We call it the rendering. We render its images by using the array of pixels. Okay, basically it's a 2D array. The 2D array and each element in the array is a pixel. So the pixel will have each pixel will have the color value to tell you its intensity, the color intensity of this pixel. Then your monitor or the screen will put it to the intensity to show the correct color or the intensity on the screen. So that's how you see rendering on the screen. So actually for this one is the natural thing, and here actually you can enlarge the small part for example maybe this one. Here, you just enlarge this one like this. When you enlarge this part, you will see there are many small flags. Each flag is actually the pixel, the image pixel. Okay. image 怎么组成的？大家知道哈，就是一个 pixel， 每个 pixel 都有不同的那个数值来描述它的颜色跟它的强度。Okay, so images can be modeled as a bitmap or a vector graphics. A bitmap is simply an array of pixels. And this pixel stores the color value. Okay, so this is simple. That is our physical pixel. Okay, for this, each pixel we will have. For this one, you can map it into. Actually, we will store a value in this pixel. Okay, so for example, we will translate this value to its corresponding intensity. Here. Okay, so we here just provide the logical view and the physical view of a small pixels. And how about the vector? For the vector graphics, the image is stored by using a line or curve shape to make up the image. For example, here we use two rectangles, the red rectangle and the purple rectangle. We use the two rectangles to describe the image. So we use the shape, we don't use the pixel. We don't use the bitmap pixel to describe the shape. Okay, so it's called a vector graphic image. Okay, you use the line, curve, or shape to describe the image. It's called a vector graphic. Okay? Any problem? So we have two different types to represent the image. One is use the bitmap, and the other is use the shape. So I think I should turn off these computers. Vector graphics are often in size, are often smaller than the bitmap because you don't need to store all pixels. You just need to store the shape or the line or curve. You can use a very small point to describe a line or curve or just some text information to report the shape, the position. Like this. It's coordinate, so you can. It's more in size, more than bitmap, and the resolution independent can be scaled without a loss of quality. But its presentation is not very realistic as the image, as the bitmap images. Here are two examples. This is the digital photograph, and this is vector drawing of the flower. Okay, you can see it's more realistic, right? For vector graphics, you can just show a very simple, use a simple shape and a line to draw the flower. Okay, here you show some transformation. For example, I just apply use the Photoshop here. I use Photoshop to get some effect. And this is also maybe you apply a business algorithm for the vector graphics. And here, I just enlarge. If I enlarge this part, I want to enlarge this part. What will it show? You can see in the vector images, it's still very clear. Okay? But for the bitmap, it's just very raw. when you enlarge this part. Because in the bitmap, when you enlarge it, you will see the pictograph clear, right? You will see the boundary. You will see like this, not very clear, it's just a blur and unclear. But for the vector image, it will certain matter. It will certain matter because if you vector images use the mathematics to compute the shape and the line and curve. So it doesn't matter when you change the resolution. When you scale it up or do something, it's still very clear. Okay, any problems? Next we talk about the moving pictures. Okay, so for moving pictures, we usually use the video or animation. So animation, video usually used by for the live action. And for animation, may be represented in another way. So here is the here shows frames from animation. We have several frames, and these frames, when you render these frames in an order, you will see this one. You slide from here to here, like this. So it's called animation. Okay, since the video or animation they require a lot of storage to store the frames. So the video is we usually use we have to do the compression for delivery. Next we talk about sound. Sound can be represented as a sequence of samples after digitization. So it's the same. We have to sample it and then to do the compilation. Okay, the digitalization is the same as the compilation, the same meaning. Okay, so CD audio is sampled at 44.1 kHz or kHz. Okay, so higher sampling rates are sometimes used. But it's sufficient for normal people because our hearing system just can hear about 22 kHz. So 44 kHz is sufficient for most people. And the audio deliver can deliver over the internet and by using some compressed version, for example, MP3. And this MP3 your file will be smaller, so it will be easier to transmit over the internet. Okay, here we talk about the character. The character set is the mapping from characters to characters code. And we also use, currently the worldwide use the Unicode to represent all known languages, including from English to any other, for example, Chinese languages, Thai language, Arabic language. All the languages are included in Unicode. A font is a set of character shapes. It has a special name called a glyph. Like this, it's several different fonts. Okay, here this slide just tell you the layout, to control the layout. Okay, so layout I think just show you two examples to show different layouts of the text. Okay, interaction. Okay, interactivity. Interactivity means that it's produced by executing the program, and the user can have some response. So the interface. Okay, so for interactivity, some media allow you to do the interaction with the media. For example, when you watch the video on your computer, you can control the timeline. Okay, you can just click something, or you can just fast forward or backward like this. So you provide a user interface for you to control the video, to control the media. Okay, in multimedia, programs are often written in scripting language, such as JavaScript or ActionScript. Okay, so JavaScript is widely used in industry, and the ActionScript is ActionScript I remember is used by Adobe company, right? Metadata. So metadata is a structural data or data. So we can attach the metadata into the media file to help to search or to classify this media. Okay, tagging is similar to metadata, but it's less structured. You just add a tag on video to help people to pass some information, some words related to this video. It's called a tag. You can just treat it as a type of a metadata. Okay.